Okay, guys, I'm on ChatGPT. You know, the AI chatbot that everybody's talking about, right? All right. So lately, I've been thinking I might do take the IBM Associate Quantum Developer exam to get a certificate. I've already got a certificate with Black Opal for quantum computing, for mastering quantum computing on the Black Opal. I already got their certification. So I was thinking about doing it for IBM, but I don't know if I'm going to do it or not, but I can at least practice um, taking practice exams on ChatGPT. So I asked ChatGPT I said, give me a 10-question exam that is very similar to the test I would take for the IBM Associate Quantum Developer exam. And then it says, here's a 10-question practice exam designed to be similar in tone and difficulty to what you'd encounter on the IBM Certified Associate Developer Quantum Computation using Qiskit blah 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 exam. The test covers Python and Qiskit fundamentals, quantum gates, blah blah blah. Okay, so I'm going to start this test right now. Okay, let's see. Number one, which quantum gate creates a superposition when applied to a 0 qubit? Which quantum gate creates a superposition when applied to a 0 state qubit? That would be H. So I'm gonna put H1. I'm gonna put H. All right. Let me go to number two. What is the output state after applying the following Qiskit code? Okay, so it says quantum circuit 1, Hadamard gate. This would be a Hadamard gate. Um, because QC means quantum circuit and dot H means Hadamard, and that means that the Hadamard gate would be on quantum circuit 0. It says measure all, so that would be it would be all right. That would be number 2 would be C. Let me put 3. But 3 would be, which Qiskit component is responsible for simulating quantum circuits? Here. I'm gonna say A. So 4, number 4. What is the result of applying 2 Hadamard gates in succession to a single qubit? Creates a Bell state, leaves the qubit in superposition, turns the qubit to its original state, and measures the qubit. I'm going to say C. Let's go to number 5. I'm going to say C, returns the qubit to its original state. In Qiskit, what is the purpose of transpilation? Convert Python to quantum assembly, simulate quantum hardware noise, optimize the quantum circuit for a specific backend, visualize the block sphere. I don't think it's A or D. I'm gonna say C. It might be B, but I'm gonna say C. If it ain't C, it's B. What does the CX-C0 gate do when the control qubit is in state 1? When it says, what does the C0 gate do when the control qubit is in a 1 state? Basically, that's what it's saying. The C0 gate will. That's a good question. What would the C0 gate do? If I'm gonna do when the control qubit is in state 1. Hmm. Hmm. It's a good question. You see, so if it's in a state of 1, This flips the target qubit, does nothing, measures the qubit, doesn't measure the qubit, and it's not does nothing. Applies a Hadamard gate. Hadamard? No, it flips the target qubit. It flips the target qubit, I think. That's A. Because it's going to flip the target qubit to whatever the control qubit is. So 7. Which of the following describes entanglement? Qubits in the zero state, qubits acting independently, qubits with dependent outcomes. Describes entanglement. Qubits in zero state. No, it's not qubits in zero state. No, it can't be that. Qubits acting independently. Could be that. Qubits with dependent outcomes. Nah, it's not qubits acting independently. It's either C or D. Qubits measured in the Pauli basis. I think it's C. Because whatever one qubit does, the other qubit does the opposite. But it could be D. Alright, so what will this circuit output in terms of measurement probabilities? Okay, so there's two quantum circuits. QC equals quantum circuit. There's two quantum circuits. Quantum circuit dot Hadamard. The Hadamard is on the zero circuit. Quantum circuit CX, control not gate, or the control X gate. The control is on the 0, the target is on the 1. Quantum circuit measure all. So that would be 25% for basis state. No. Always 0, 0. No. It's either A or D. It's either A or D. I'm gonna say it's A. Well, I'm gonna say it's A. Okay, so I got two more because they should be 50-50 in a 50-50 state of entanglement. And the reason why I know, looking at these numbers, this means that it's entangled, the two qubits. This qubit is entangled with the 0, 0. With this qubit, that's 1, 1. That's an entangled qubit. Those are two entangled qubits looking at that format. What is the default simulator used in Qiskit AER? What is the default simulator used in Qiskit AER? Chasm simulator? State vector simulator? AER backend? Unitary simulator? I'm gonna say Chasm. Could be wrong, but I'm gonna say Chasm. Number 10. I'm gonna say number 10, I'm gonna say which command is used to install Qiskit? Conda install Qiskit core, PIP install Qiskit, PIP install Qiskit IBM. Oh no, that's D. I think it's D. So we're gonna go with D. Let's see. I finished the test. Let's see what I scored. See how well I did. Let's see. Out of 10 questions, let's see how well I did. Okay, so I got 8 out of 10 right. I got 8 out of 10 right. It says your answers and results. Your answer, correct answer. So the X is the ones I got wrong. So I got number 3 wrong and I got number 10 wrong. So for number 3, the answer is Qiskit AER handles simulations. And then for number 10, it says installation command is PIP install Qiskit. Okay, so I got 8 out of 10 right. I would have passed the test if I was taking the IBM Associate Quantum Developer exam. And it had 10 questions, I would pass the exam. But the exam is actually 60 questions, so it's not really 10 questions. It's really 60 questions. But with this test, 10 questions, I passed it. But number 3 would have been AER, and number 10 would be PIP install kit. Okay, so alright, so that's it for this video. Like I said, I'm thinking about taking the IBM Associate Quantum Developer exam so I can get my certificate with IBM saying that I know quantum computers at a very good level, very high level. Like I said, I'll see. That's it.